Welcome back. In this video, I'll continue with the vector line integral. So if you have not checked the first video on the scalar line integral, so I'll leave the link in the video description below so you can check that out before you continue with this. So now, but before you even go to the vector line integral, there are some questions that I want us to look at together under the scalar line integral. So for instance, this question here now. So you are given this dx from A to B along that curve. Now, the line integral is of this form. We have p dx plus q dy. But in this case, there is only dx term, no dy. So all you have to do is I think this is even simpler because you don't have to bother, like stress yourself combining them again. So all you just have to do is to focus on that term only. So, and you have been given y in form of x, in terms of x, okay, as a function of x. All you just have to do is to replace the y in the equation with the x in terms of x. So, and then also, and this is only the x that's changing, right? So, I mean, it's the only x term that we have. So, from your point, it's only from 0 to 2 you will use to set those are the boundaries for your integral. So, because you are dealing with x here. So, the integral will go from 0 to x, and then you evaluate the integral. Very simple. So, that's all you have to do in this question, okay? And the same thing, if you are given maybe the y, for instance, so you have to change everything to y. Every x will change to y. So, and then you find dy dx. In this case, we find dy dx so that we can get dy in form of dx. But there's not even dy in this question that you want to replace with 2x dx. So this is not useful here. Okay. Then another question. Now look at this question. But before I solve this, let me solve another simpler one. Now, one thing I want to tell you is that most problems that students have with this kind of question is how to parameterize. Now, for some questions that you are not given the parameter already, like they don't parameterize your variables for you already. What you have to do is to express the y in form of the x. Now, some students still find this difficult. Now, this is what I will tell you. If you see in that question that it's a straight line, right, all you have to do is to form the y equal mx plus c equation. In that case, you get a y in form of x. Now, how do you do that? You first have to get this m. M is this loop. So this is y2, x2, y1, x1, right? And then you get the y over dx. So you get 1 for that. Now, after you get that, remember this equation, y minus y1 equal mx minus x1. Okay? So, and then you will check again. What's your x1? Sorry, y1. y1 is 2. So that's y minus 2 equal x minus x1. x1 is 1 from here. So you can see, so from here you will just like find the value of, you just simplify the equation. So you just have, replace the m with whatever you get, and then that will be y minus 2 equal x minus 1. And then if you collect the like term, or you rearrange, so that y is equal to, so it should be y equal to x plus 1. And most of the time, you can get these things even from that point themselves. You can see your x and y. How do you get y here? It's not by adding 1 to your x. So if you're adding 1 to your x, that means that y is equal to x plus 1. And see, it's still consistent. The same thing in the second point too. To get 4, you must add 1 to your x, which is 3. So y is equal to x plus 1. So that's what you want to first get. Once you're able to get the relationship between x and y, I mean the equation connecting x and y, then everything is simple. You just have to find the y dx so that I can express the y in form of the x. And then you go back to your equation, your integral, and then you change all the y to x. So y here is what? X plus 1. Y square will be x plus 1 square minus x. dy is now equal to dx, you put it. So you can now integrate. And since it is dx, so from your question, it is from 1 to 3, your x, from 1 to 3. So that means your integral will be from 1 to 3. And then you integrate that, then you get your answer. Hope you understand. So that's very simple. Now, there is one that I omitted. Good. So this one, now look at this question. They said you should integrate this from point 0, which is this having this coordinate, then to point A. That's OA, line OA. So now they now said, now they split it. You don't go straight to it. So they said first along the line y equals 0. That means that you are going from the starting point, which is 0, 0, along line y equals 0. That means from this 0, point 0, which is 0, 0, then you go along the line y equals 0. When y is equals 0, that means y is not changing. Okay, so it's along this line. That's your C1. right? So that means you are going from 0, 0 to what? Y is not changing, y is equal to 0. So to a point, let's call it A, of where y is equal to what? Where y is equal to 0. So don't forget, where are you going? You are going finally to what? 1, 4. So y is equal to 0 along the line. So you are going to what? You go to 1, 0 first. Then after you get there, don't forget, this is where you're going. You are going from 0, 0 initially to what? To 1, 4, which is at this point. This is where you are actually going. But you want to first go to this position first, right? First go along this line. They say you first go along the line y equals 0. So that means that your x is still changing, but your y is 0 at that moment. Then after that, then from when you get to what? When you get to 1, 0, which is this point, where y is not changing, still 0, and then your x is of course changing. Then after you get to that point, you then go to what? You then go to b, which is 1, 4. Along the line x equal 1. At that point, x is not changing, as you can see, 1, 1. So that line, you can see that x does not change along this line. So from 1, so from the along this line, okay, to b, which is 1, 4, which is this place, 1, 4. So and that integral is also simple. Okay, so if you want to do the first one, right, from 0, 0 to what? To 1, 0. When they tell you along the line y equals 0, what you first have to think is that you are not going straight to that final. So you have to start from the initial, then y is equal to 0. That means that y does not change because y was 0 here too. So that means that y will not change in that first place you are going, right? 0, 0. It's only the x that you have initially here from this part that would change to 1, as you can see. So this is how you integrate. Of course, the y will be 0 because it doesn't change and it's a constant. Y does not change, it's 0. So then you have this. Then anywhere you now see the y in your question, you see y, you put 0 there. So every time here now, that means it's equal to 0. Okay, and then you put 0 here too. So everything will now reduce to what? X squared dx. That's all. And that's what we have here. You have x squared dx. Now only x is changing, and it is changing from what? From where? From 0 to 1. I hope you understand. So that's why you put 0 and 1 there. Then now the second point is from 1, 0 to 1, 4. In this case, x is not changing. You can see it's a straight line, vertical line. X is not changing. X is constant. Is 1. So dx is 0 in this case. Dx is equal to 0. But y is changing. So your integral will be from what? From this is y1, 0 to y2, which is 4. Now, anywhere you see dx, you put 0. So that means that all this first term here will go, right? Then anywhere you see what? Anywhere you see x, you put. So x is not changing. So what's now the constant value? So it is 1. It is 1, 1. So anywhere you see x, you put 1. So you put 1 here now. So 1 times y dy. So that will be your what? Y dy. That will be your second integral like that. So that's what we have here. Y dy from 0 to 4. Then when you get the second answer, then you can add them together. So, instead of it to go from 0 to b, you are going from what? To 0 to a first, and then from a to b. So you now add the two answers together. That will give you your normal o to b. So that's how you solve questions like that in case you are given. Okay, so how to parameterize? Again, if it is a straight line, please use this formula. First find your slope. After you find your slope, then use this equation to get the relationship between y and x. And of course, sometimes when you just look at the points, you can also determine that kind of relationship. So if you are smart enough to do that. So now let's look at the vector line integral. I wouldn't want to dwell much in that topic. Now, so line integral, basically, that vector line integral is like you be given a integral of they'll give you a vector space, let's say A, and it will have components. It will have x, y, and z. They will not ask you to find a dot dr. So what will make you to get this dr you'll be given from those points, you get that. For instance, in this question, you are given a to be this. This is your first term, first component, second, and the third component. Okay, and then they ask you to find a dr. So from this point, you get your dr. Now, one thing is sometimes it will be parameterized. This has been parameterized now. So that means that all your x, y, and z, you change them to something containing t. Okay, so in your question now, you want to do first for this a, you change all your x to t, all your y to t squared, and all your z to t cubed. Now all the dx, dy, because if they ask you to find integral of a dr, is like integral of ax dx plus ay dy plus az dz. So this is your ax, the first term, ay, and az. That's all. I mean, this integral they want you to find, which is integral of a dr now, will just be integral of 3x squared minus 6yz dx plus 2y plus 3xz dy, and then plus 1 minus 4xyz squared dz. This is what they want you to do. So since it has been parameterized, so just change all your x to t, all your y to t squared, your z to what? T cubed. Then all your dx you have to change, because from here now you know x is what? T. So that means that dx dt equal 1. So that means dx equal dt. Now y equal t squared, dy dt will be what? Sorry, dy dt will be 2t, and then dy equal 2t dt. So you do the same thing for what? For z equal t cubed. You find dt, dz dt. So here, anywhere you see dy, you'll be replacing it with what? With 2t dt. So everything will now be in form of t. Where you see dz too, if you do it correctly, dz will be equal to 3t squared dt. Replace dz also with what? With this. And then x, y, and z, you replace them with t as well, with appropriate t, because you have been given x is t, y is t squared, like that. And then you now integrate. So I think this parameterization part is the most difficult for most of you. Now I hope you get it. Now if you are not given in terms of t, when you are not given in terms of t, how would you do it? Right? How would you do it when you are not given in terms of t? This is where I'm going. So what you would do in that case is that you are given those points, right? From 0, 0, 0 to 0, 0. First thing is that sometimes you don't have to this is how to parameterize in that case. I'll come here, right? I'll come here to explain. But sometimes you don't have to use those formula. When you just check, you see that x, y, z. X and y does not change here. It's only z that's changing. So everything is now easy for you. Right? Everything is easy, because that means that after you write your integral, okay, which is what? Integral of, which is integral of 3x squared minus 6yz dx, and then plus 2y plus 3xz dy, and then plus the last term also dz. What you want to do is, I want you to get is that you just want to make everything to be in the same variable. That's your point. That's what you want to do. Now, since your x, y are not changing here, they are the same. That means your change in x is 0. Change in y is also 0. So that means this term will go. This term will also go. You are left to what? To integrate just this part, 1 minus 4xyz squared dz. Then dz, right? So how does z change? It changes from 0 to 1. So from 0 to 1. You get the logic. Now you have to change x and y to what? To z. How do you do that? You don't have to change it to z basically, but you have to change it. They must not be there. So then from your question, they are constants. They don't change. They were what? They were 0, 0. So you put 0, 0 there. When you put 0, 0 here, what will you have? You have integral from 0 to 1. If you put 0 for x, 0 for y, what would you have? Everything here will go, right? So you just have what? 1 minus 0 dz. So your integral here will just be what? Integral of 1 dx, dz will be what? Y is like z to the power of 0. So that will be z 1 over 1. That's z. So your answer is z from 0 to 1. And that will be 1 minus 0 equal 1. I hope you understand. Then, if you want to do for the second one too, I want you to get it. If you want to do for the second one, the same thing. If you are able to check and you find out that some of them, right, are constant, your work is simple. You don't have to struggle with this parameterization. Even though you can do parameterization, but it will be long. You don't have to do it. You still get the same results. Cancel them out. Find the anyway, let's continue. Now for this second part, 0, 1, 1 to this, you can see that y and z also are constant. This is x, y, z. but 1 1 for y and z, 1 1 for y and z here too. It's only x that's changing from 0 to 1. So what does that mean? This part will go, this part will go, because change in y will be 0, change in z will also be 0. It's only dx that we're having. So what would you do in that case? You have integral of 3x squared minus 6yz dx. So dx is from 0 to 1, right? So you have to like find out, you have to make everything here to just be what? To just be x. All the y and z, we change them. And they are what? They are 1. They are not changing, they are 1, they are constant. So you have to change them to integral from 0 to 1, 3x squared minus 6, 1, 1 dx. And then your answer will be from 0 to 1, 3x squared minus 6 dx. And then this is what you have to integrate. You see now it's now in form of x. So just integrate that and then you get your answer. For the last one, this is where I'm going. This is where you have to parameterize. Even though you still do not need to parameterize. Let me explain. Because you might be thinking that dx, none of them is equal to 0 here. Dx is not equal to 0, the y is not equal to 0. Yes, but you still don't need to use this parameterization. Even though I'll still explain it, but let me just teach you the short method. You can see that the same way x change is equal to the same way y change is equal to the same way z change. It's not the same in this case. I'll use this example because they change by, it's from 0 to 1, 0 to 1 for y2, and 0 to y for z2. So the way they are changing is the same. So if you look at this now, this change from 3 to 2 to 3. So you cannot say dx here is equal to dy. This change by just 1, this change by just 4. So they are not equal. So, and if you say that dx is equal to dy, that means that we can say that x is equal to y if you want to replace them. Do you get the logic? So you can just like say they are equal to the same thing. Maybe t. Let me explain. In this case, what I'm trying to say in essence is that they change the same way. And if it is like this, we can say integral of, that means that x will be equal to y and z. All of them are the same. Because you can put integral here. Integral of dx will give x, integral of dy will give y, integral of dz will give z. But if you don't want to do that, you can say they are equal to t. Just change everything to t. So what you will now do is that x, you can now say x is equal to y and z. Anywhere you see y, you can replace it with x because y is equal to x. Anywhere you see z, you can replace it with x. You can do it that way. And dx, you will change all the dy and dz to dx. Just integrate like that. I hope that's clear. Now, what if, so in that case now, this will become what? 3x squared minus 6x squared, because this is now x, this is also x times x squared, dx, plus 2x, y is x, right? Plus 3xz will become 3x squared, because z is x. dy is what? dx now. Plus, then the same thing. So it should just be 1 minus 4x to the power of 4. This is x, this is x, this is x squared. X times x squared. That's x to the power of 4 dx. And this is what you integrate. Everything from what? 0 to 1. Now, how do you parameterize? In case you are given questions like this one below, whereby dx is not equal to dy, how do you parameterize? Parameterization is like you start from, and if you are parameterizing, it will be from t equal 0. So you want to change everything to t, right? So from t equals 0, then you do for t equal 1 as well. Now, how do you do it? Remember this equation, x equals c plus kt. So for x, you change it to this equation in form of t. For y, the same thing in form of t. For z, the same thing, c plus kt. So if it is x, c1 plus k1t, y, c2 plus k2t, z, c3 plus k3t. Now, you have to be substituting for t. You are starting from 0 always. Okay, so if you change this t to 0, because at the beginning you say t is equal to 0, right? If you put 0 here, everything here will go. Everything here will go. Everything here will go. I hope you understand. Then you substitute for x2 in your first point you are given. That's when you want to parameterize. So for your first point, you're having 0 for x. That means that if you put 0 here, that means that c1 will be equal to 0. If you put 0 for y2, c2 will be equal to 0. If you put 0 for z2, according to the first point, c3 will be 0. Then you go to the final. To the final, it is 1, 1, 1. So you put 1 for x because it's still the same equation, x equals c1 plus k1t. Now in this final, x is 1 equal, you have gotten your c1 already for x to be equal to 0 plus k2t. T is 1 here. Don't forget for the final. I hope you understand. What would you have for k now? You are trying to find the constant. You want to get, your aim is to get x in form of t. So you have to find, and you say x is what? X is c1 plus k1t. So you have to get these two constants so that you can express x in terms of t. And those two constants are the ones we are trying to find now. So once you have found c for the first point, then you found k for the second point. So this is exactly what we did. So t is 1 for all of them, just like t is equal to 0 for all of them in the beginning here. So you put 1, 1, 1. And then for the final point, you put what x is, what y is, and what z is. And whatever you get for your c in the first point here too, then you can get your k for each of them. So after you are able to get your k, you have gotten your k. All your k are what? K1 is 1. If you do it, K2 is also 1, K3 is also 1. And your C1, C2, C3 are also 1, 1. Are 0, 0, 0. So then that means that in your equation of x equals C1 plus K1t, all of them, y2 is equal to C2 plus K2t, z is equal to C3 plus K3t. All your c are already 0. So that out of the equation. Then what are your k? 1, 1. So 1 times t, 1. So x of t is equal to t, y is equal to t, z is equal to t. So in your equation now, you have to change everything to t. I see that it makes sense with my analogy that dx, dy, and dz are all equal, according to just speculation from what we just see from the points. So from our parameterization, you can see that it is equal to the same thing too. And that means that if you find your dx, dt here too, it will be the same. Okay, so everything will now be in form of t, and you change dx to dt because, of course, if you do dy, dx, dt here, they will be the same because it will be equal to 1. So that means dx will be equal to dt. Do dy, dt here too, it will be equal to 1. So dy is equal to dt. So you now change all your dx, dy, and dz to what? To dt. Everything will now be in the same variable. You can now integrate. I hope that's clear. So in that case now, this one will just be 3t squared minus 6t squared. Okay. Then dt. Do the same thing for all of this. That's just it. So look at this question, for instance, in case you are given, okay, so this is what you have. And by the way, I'll be solving these popular questions that some of you have been sending to me to solve for you. I will solve those ones too after this. So, and in fact, they should be simple now from my explanation here now. So in this case, so if you want to solve this kind of question, you are given to evaluate. So y dx, z dy, and x dz. So from this point to this point, just parameterize. So if you parameterize, this is the formula you will use. So t, you start from t equals 0. So if you put t equals 0 here, everything will go. So for your first point, everything here will first go. Note that because t is equal to 0. So your x will be equal to t directly. So you can see all your c1, c2 are equal to x and y, like as we have it here. Then if you want to do for t is equal to 1, that means that k times 1, that's what you have here for your second point. Now, what will be your c? You have gotten it, 2 for the first one, 0 for the second one. Then equal to what? X. What's x for the second point? Second point is 3, 4, 5. The first point was 2, 0, 0, right? Like we have it here. So then you put them 3, 4, 5. From here you get your k, k1, k2, k3. And I use those two words to write your equation again. So you get x in terms of t now, you get y in terms of t now, and then you get z in terms of t. So this is how you basically parameterize. So when you are able to parameterize like that, then you can now go back to your equation and substitute. So you can now substitute x in terms of t, y in terms of t, and z in terms of t into this equation. And that is what they have here. It was like y dx, right? So what's your y now? Y is 40. Okay. Then dx is now dt. Because if you find d, so this is from where you know how dx will equal dt. Because if you find dx dt here, you get dx dt will be 1. So dx will be equal to dt. Plus in the equation, we have z dy. Z is what? 5t. What will be your dy? Dy from here, it will be dy over dt equal 4. Is that not? From y is equal to 40. So dy equal 4 dt. So that's why dy is equal to 4 dt here. And then they do the same thing for the last term, which is the last term is x dz. So x is what? T plus 2. Put it here. Dz. If you find the z from here, z is 5t. Dz over dt will be 5, and dz will be 5 dt. So basically, that's just how you integrate. And then your limit in this case, the boundary for your integration will be from 0 to 1, because you are integrating the t from the so and t start from 0 to what? To 1. That's what you choose. If you choose any other thing for your t, the same thing. Then, if you do the same thing for the second segment, like we have it here, here you can do something. Here now, good. This one is easily predictable. Dx will be 0 here. Dy2 will be 0. Do you know why? Because they don't change. X doesn't change, and y doesn't change here too as well. So it's only z that is changing. So that means that the dx term, where is it? You cancel it. The y term, okay, you cancel that too, right? Well, the z, this is only thing you'll be having left, x dz. But it's not also in form of dz. So what is your y? What's your x? So from this formula, x is 3. X is a constant, 3. So you put 3 dz. That's what you integrate. Though, mind you, you can still use the formula of parameterization to get it in form of t, but that will be too long. You still get the same result. Now, let's say this last term is not x dy dz. Let's say it is x y squared dz. Y here will just be what? Will just be 4. It's also a constant, doesn't change. I hope you get now. So it will just be 4 squared, which is 16, times x is what? Also a constant, which is 3. Then dz. That will now be, I don't know. So just multiply this dz and integrate it. That's all. Now let's see what they got from their own parameterization. When they parameterize, they do all the parameterization. So they eventually got, what did they get? Okay, for line segment 2. So let's try our own answer. Our own will be what? It should just be 3 dz. Abi, because this is an example from me. So this will just be 3 dz because x is constant, it is 3. Now it is dz. So from 0 to what? So it's from 5 to 0. That's how z is changing. So from 5 to 0. So if you do this integration, it will just give you 3z from 0 to 5. I mean from 5 to 0, 3z. So that will be 3 times 5 minus 15 minus, hope I'm correct. Yeah, minus 0 now. So 3 times 0. So your answer should be 15 if you do it that way. So your answer should be 15. So they got minus 15 here. Sorry. Okay, I'm the one that made the mistake. Excuse me, please. It is from 5 to 0, right? So from 5 to 0 means that 5 is the beginning. I hope you understand. I made the mistake. So if you do from here now, it should be 5 to 0. So your answer will be 3z, right? From 5 to 0. So you have to put 0 first. So that will be 3 times 0 minus 3 times 5. So 0 minus 15. Your answer will be minus 15. I hope you understand. So your answer will be minus 15 for that. I hope you see. When they parameterized, they didn't get it to be 3, but eventually everything was in form of t. But what they got was what we got to. So that's just it. Now let's look at these examples. So all you just have to be doing for these questions is that, let's start from 116. It will just be 1 minus x put dx, that's the first term, plus 1 minus y squared put dy, and then you integrate it. That's what you want to find. That's your integration. Now check it. 0, 0 to 1, y. That means dy is equal to dx. So if dy is equal to dx in this case, they change the same way. You can just change everything to dx. 1 minus x dx plus 1 minus x squared dx, like that. Like I told you. So then it should be from 0 to 1. Mind you can also parameterize, but this is how I'm doing my own. So you will have what? 1 minus x plus 1 minus x squared dx from 0 to 1. So that will be minus x squared minus x plus 2 dx from 0 to 1. And then when you do it, you have minus x cubed divided by 3 minus x squared divided by 2 plus 2x, all from 0 to 1. It's only one that matters. So you have 1 cube over 3 minus 1 squared over 2 plus 2 times 1. So minus everything will be 0 for this for the lower limit. So you have um, minus 1 over 3 minus 1 over 2 plus 2, right? So what would that give? That will give, you find this 6 minus 2 minus 3 plus 2. That's minus 5 over 6 plus 2. 2 is minus 5 over 6. 2 is plus 12 divided by 6. You get 2, right? So that will be minus 5 plus 12 divided by 6. So minus 5 plus 12, that's 7. 7 over 6. So answer is 7 over 6 for the first one. For the second one, you do the same thing. You have x squared minus 2 dx plus z dy. So integral from, so that's what you want to do. So don't forget, first term is dx plus second term dy. Even though in this second term now it is z that is given, but it is dy. So that's how you would express your g dot dr that they ask you to find. And they said from what? From 0, 1 to 1, 1. What's that telling you? 1 does not change for y. So dy is equal to 0. So it's only x that's changing. So all this term will go. So it's only this part you are integrating. And since only x is changing, it is changing from 0 to 1. So that will be integral from 0 to 1. I hope that's clear. Integral from 0 to 1. And yes, so integral from 0 to 1 for x. So in case y is in this expression now of dx, you have to change the value of y to what? To 1 because it's a constant. So you integrate this. So you get x cubed over 3 minus 2x from 0 to 1, and that will be 1 over 3 minus 2 times 1. That's minus 2. So that's what you have, because that'll be minus everything when you put 0. 0 minus 0. Right? 0 cubed divided by 3 minus 2 times 0. So everything will be 0. So here you have 1 over 3 minus 2 will be in terms of 3, that will be 6 over 3. Right? So you have minus 5 over 3 for your answer. I hope you'll be able to try the remaining question. I don't want it to be very long. So h will be what? For the h, it will just be I mean 118. So that would just be, sorry, I'm trying to, so it's actually very simple. For that would be, I think I should stop at this place. So that would be y then dx plus z squared minus 5 dy, right? Dx, dy. Then you have another term, that will be dz. Now, so you do the integral. Okay, now if you check that, x does not change, so dx is 0. This term has gone. That means that it's only this that will be left for your y. So integral of z squared minus 5 dy. Okay. And good. This is how you think about it. Good. So one thing is, now, for the first one, I said for 117, I said integral of x squared minus 2, I said dx, right? And then I said plus z dy, is that not? So now, this is what you will do. In case of this one, whereby the z is what? The z is not given here now. So you think of it this way. I'm talking about 118 that I'm solving here. For the 118, I said x is constant, right? So the second variable will be your what? Will be your y, like that. So you think of this as your y, or you call it your z. In this case, it will be xz, xz, because you'll be given two variables. So the first one is your first variable you are given. The second one is your second variable. Like, I mean, if you are to do it correctly, this should be y, z, y, z. Because in your question, you are given y and z. Those are the two variables. So that means that this is y and this is z. This is y and this is z. So you now say y is constant, y is not changing. So normally this question should be dy, okay, and this should be dz. The first term, dy, plus the second term, dz. That is how it's supposed to be. I hope you understand. So the same thing for this one that we have solved before. If you change that, you still get the same result, by the way. So that by the time this goes, then you'll be left with this dz. So this one will now be dz. I hope you understand. So that is how you are supposed to do this question. So in case you now see y here now, you cannot change that y to that constant that you see here, which is the constant is 1 here for y. Okay. So you can now integrate this, and then you have z cubed divided by 3 minus 5z. From how is the z changing? It's changing from 1 to 2. So from 1 to 2. Then if you put 2, that will be 2 cubed divided by 3 minus 5 times 2. Then you do minus 1 to the power of 3 divided by 3 minus 5 times 1. Don't forget everything in brackets. So this one will be, so I believe this should give 8 over 3 minus 10 minus in bracket of 1 over 3 minus 5. 8 over 3 minus 30 divided by 3, that will give 10, minus 1 over 3 minus 15 over 3, that will give minus 5. So this will give minus 22 divided by 3 minus in bracket of minus 14 divided by 3. This should give minus 22 divided by 3 plus 14 divided by 3, and that will give over 3 minus 22 plus 14. That should give 8 over 3, right? Yes. No, is it 8 or minus 8? Minus 8, I think. Yes. So minus 8 over 3 for 117, for 118. Yes, minus 8 over 3. So that is how you solve the remaining one too. I want to cut the video short at this point. So I wish you the very best in your examination. So if you have any other question regarding line integral, so you can send it to my number as displayed on the screen below. As displayed on the screen, as you can see. So I wish you the very best. Ensure you like this video and please subscribe to my channel for more educative content. I believe in your second semester I'll be offering Math 205, the what was the name? I've forgotten the linear algebra. Yes. So by God's grace, I'll be making more video on that as well. So ensure you like this video and then subscribe to this channel for more educative content. Thanks for watching.